Optical Transport Network Part 3. Welcome back to our Optical Transport Network series. In first two parts, we explored the foundation of OTN, its architecture, layers, and how it maps different client signals. In this part, we will take it further. Uh, how different audio signals are multiplexed, the protection mechanisms that keep your network safe, and how modern network management systems handle OTN deployments at scales. So, in OTN, the optical data unit (ODU) comes in different different rates and sizes. These includes, as we have studied, ODU 01, ODU 0, ODU 1, ODU 2, ODU 3, and ODU 4. Each one corresponds to a specific signal client signal rate. Let's quickly recap. ODU 0 is 1.25 gigabit per second, and it is used for gigabit Ethernet. Audio 1, 2.5 bps, used for STM16 or OC48. Audio 2, gigabits per second. STM64 or 10 GA LAN. And audio 4, audio 3, 40 gigabits per second, audio 4, 100. Here is the key part. Audio multiplexing allows you to pack multiple lower rate audios into a higher rate audio. For example, I will next slide. Example. Order audios into higher order audios. For example, 4 into audio 0. Now, audio 0 is 1.25 gigabits per second. So 4 into audio multi multiplex into 1 into audio 1, 4 into audio 1 multiplexed into 1 into audio 2 and 4 into audio to एक measure multiplex into 1 into audio 3 and so on. This is done using audio containers and tributary slots. Using each higher order audio has a set number of tributary slots like compartments in a train, for example, which carry the lower order audios. So if you are using Huawei OSN 9800, these mappings happen inside cross connect boards or TNC-TB boards. Why is this important? Why is this important? It enables flexible bandwidth allocation, efficient grooming, efficient grooming, and makes OTN the backbone of multi-service transport. I will cover the next part of further multiplexing and OTN protection mechanism in the next video. Thank you very much.